So I'll be doing the multiple choice timed assessment twice, and the first time I do it, what I'm gonna be doing is basically cheating. You shouldn't be doing it. If you do it, it in fact is cheating. If you ever do it the way I'm gonna do in the next few minutes, don't ever admit to it, because again, it's cheating just unambiguously. But I'm gonna do it not as a demonstration of anything you should do, but as a demonstration for me to test what the state of the art is in terms of generative AI, which, as I've been demonstrating with the problem sets, can actually work as a tutor. It doesn't necessarily have to be a cheating tool. But while you're doing the timed assessment, one of the rules that's in effect, that's not in effect when you're doing homework, is that no outside help is allowed. That's why using generative AI is cheating no matter what you do with it. Having someone else help you is cheating. Having Google open is cheating. You could use Wolfram Alpha and I guess Google, as long as you're using it as calculator. So again, with no hint of joking or joviality or anything like that, with no ambiguity, what I'm gonna be doing for next, I think about 5 minutes, is cheating. So please don't do it. Now, I've with the ChatGPT 4.0, I've been able to do copy and pasting and cheating fairly more efficiently. When I was trying this out with my Physics 4A class, I could have finished the 10 question set in about 5 minutes. So let me get through this again. Cheat my way through. You shouldn't be doing it. And the first time, and then the second time I'm going to do it myself and hoping to beat ChatGPT either in terms of time or in terms of accuracy. And I will tell you, in my other class I've been beaten. I've been beaten on time once. Yeah, on time once. And on accuracy, I guess depending on how you count it, I tied or so. So it's gonna be just it's just gonna be a personal record goal for me, just to keep ahead of ChatGPT as long as I can, because I do imagine at some point I will be beaten. Now, in order for me to cheat more efficiently, I'm gonna give ChatGPT a prompt that's different than my usual prompt. So I'm gonna tell it, "Hi, I'm working through a timed multiple choice question set," and I won't be telling it that I'm cheating. And I'd like you to give me the answer to the question as quickly as possible, possibly followed by a brief explanation of the correct answer. Can you do that? And then it'll say yes. And then once it's done, then I will work through the 10 question set as quickly as possible again. What I'm doing is cheating. Don't do it. And if you ever do it, don't admit to it. So, with that, so because I'm basically focusing on cheating, I'm not, I like to describe what I do as turning my physics brain off. I'm not really reading the questions. I'm not thinking through it. I'm just focused on getting the answer, entering the correct answer. Describes a force. Whose magnet? Okay. It's probably correct, but again, my physics brain is turned off. I'm not really thinking about what I'm reading, other than to make sure that I'm marking the correct answer as given by ChatGPT. Charge induces a polarization in the tissue tissues. I think it's this one. Alright. And then we'll see at the end if ChatGPT gets all the questions right, and then go from there. So in the past semesters, it used to take longer because I had to copy and paste the text, and magnitude of acceleration is copy and paste the text, and sometimes with the mathematical expressions I have to manually type it in. But by being able to copy and paste the screenshots, it's it takes a lot less time than having to copy the text and then making sure it's formatted correctly and all that. A cylindrical circular base. Maybe this one. Yeah, and you can see that I'm not even reading the whole answer because I'm just making sure I'm picking the right unique choice. Okay, I'm gonna have to do this as two-part. So I'll do this, and then hopefully ChatGPT will understand it in two parts. Surface electric field magnitude is constant surface. Okay. So this and then so I'll say choices in second screenshot. I think it probably infers that through whatever algorithm it does. S3, okay, I'll mark that after I copy this. S3, again, I have my physics brain turned off, so I'm not even evaluating is that correct or not. This is why you shouldn't cheat, by the way, because when you cheat, you are basically doing, you know, you won't remember anything, you won't understand anything. So that's really the main arguments against the cheating. Not because you'll get caught necessarily, not for any other reason than that you won't be learning if you are cheating. So yeah, it'll give me an answer while it's doing that. Let me copy the next one. Yeah, it's yeah. Is that correct? I don't know. I didn't read the question. Might be correct. If it's about dipole distribution with the voltage between them, then yes, that is correct. Let's see. Okay. All right, I'm gonna have to do this in 2 screenshots. I don't think I need the image discretion. ChatGPT will figure that out. So correct express KQ squared over 2R. That could be correct depending on what the wording in the question was. Choices in second screenshot. And because I'm cheating, I didn't even really read it through any of the things. So that's the last one. After I enter the answer, I'll scroll up, check the time, and then go from there. E is independent of area. Is it? I don't know. I didn't read the setup. If the voltage is constant, then maybe not. If the charge is constant, maybe. All right. So, okay, about 5 minutes. So that's how long ChatGPT took. Let me make sure I answered everything, and then I'll submit. So it might have gotten everything right, might not have. I wasn't really reading, so I don't know. So 5 minutes, 90%. Oh, how am I gonna beat it? So I'm pretty sure I cannot beat it on time. I don't think I can actually answer 10 questions in 5 minutes and hope to get 100%, because I think that's gonna be tight enough time where I'm going to make mistakes. So when I do my own attempt, I'm going to just focus on getting the answers right, so that I'm gonna lose on time, but I'll still beat it on accuracy. Before I do that though, let me find the one question that it missed and make sure that you have the correct explanation. So, so that you are not, having watched this video, you are not ending with just something's wrong. I don't know which one. So, okay, inverse square law, and I think this was right. Yeah, double the distance, 1/4. Yeah. So whatever explanation gave, it must be correct. I'm not reading it. If the answer is right, the explanation is probably right enough. Plus rod is charged, tissue paper, induced tissue attracted to the rod. Yeah, I think that's right. And explanation is probably also right. This number question, well, I guess I can follow its work. So you set up the electric field, release magnetic acceleration using the value of charge. Yeah, mass. Okay, so it's doing, yeah, acceleration is that. Doing the calculation, I think, so power of 10, 10 to the minus 13 plus 31, so 10 to the 18, yeah, and then 1.6 divided by 9, yeah, so I think that's right. So yeah, I think that's correct. Question 4, Gauss law, find the electric line. Due to an infinitely long line, yeah, you'll need a cylindrical surface, which I think is described by this. The perpendicularly, yeah, through centers of the bases, yeah. Yeah, so that's correct. So whatever, yeah, so whatever explanation it gave is probably correct. Question 5, closed surface consisting only of, oh, right. Yeah, usually in all the examples you'll find that either the electric field magnitude and the direction relative to the surface normal are constant, or the surface normal is perpendicular to the direction of electric field, so that the electric flux ends up being zero. So that's correct. Yeah, 6. Net charge of, so the sphere itself has plus 2q on it. If there's minus q in the cavity, then there must be charge of plus q in the inner surface, so that the electric field immediately outside the cavity is zero. So it's got net charge of plus 1q remaining on the outer surface. So spherical surface is shown, which has the most positive net electric flux. Yeah, as S3, because S1 has a negative electric flux. S2 by the setup has 0 for these particular numbers, and S3 has plus 1q. Yeah, that's right. And I think this is randomly generated, like this wording is randomly generated. So some of the choices will have actually different surface being right. And the explanation is probably correct. Okay, question 7. Uniform spherical shell of charge. Yeah, electric field is 0, but the potential won't be 0. With the potential at infinity being 0, potential inside the shell won't be 0. Yeah, so that's question 7. Yeah, I think that's correct. 3 charges. Okay. Find the voltage at point P. Yeah, that's gonna be 0. Because the superposition principle, like from this, they add up to 0, and because it's a voltage not field, you don't have to worry about direction. So yeah, 0 volt is correct. Does it go through detailed calculation? Now these distances are wrong. Because this actual distance to point B is not the same as L. It's some factor of L. But the fact that it's got these distances wrong doesn't matter, because the main point of the question was that you figure out, oh yeah, from superposition principle, voltage at center is 0 with these specific charge arrangements. Question 9. Okay, it must have missed the question 9 or 10. So putting together a positive uniform spherical shell of charges, work on it, pushing them together. It turns out this higher potential. Yeah. Yeah, this sounds right. So it's the total charge divided by 2 to, you can interpret it in 2 different ways. It either comes from doing the integral of bringing charges together, or from if you just count the voltage times charge at every point, that double counts the interaction energy. So there's that factor of 2. So yeah, does it explain? It doesn't explain the factor of 2 or integrating the, yeah, when you do that, you get the factor of 2. Must have missed the last one. That's interesting. Yeah. So it missed the fact that what's being held constant is plus minus q. So that means increasing the area decreases the surface charge density, which changes your electric field. Yeah. So how did they miss that? PHYS. Yeah, but the question never specified the V, and so it misunderstood the question. Yeah, and I think this question also has 2 versions. In one version, it holds a V constant. In another version, it holds the charge constant. Let me double check. Or can I? Too much work to do. I'm pretty sure I programmed this with a randomized thing, which is that what are you holding constant? If this is the voltage, then yes, this answer is right. But if it's plus minus q, the charge that's being held constant, then voltage of plate labeled B is higher is correct, and the rest are not correct, I think. Yeah, E is not inversely proportional to distance. Voltage difference between A and B it's proportional to distance, not inversely. And as I was saying, this is wrong because while Q is being held constant, the electric field will depend on the surface charge density. And yeah, voltage at A is not higher. Good. So you missed this last question, which I do think is a kind of a tricky question in that you have to know electrostatics as well as I do to spot the trick and stay clear of it. So with that, I'm gonna attend to this question a second time. This time not cheating, just using my natural ability. And I do need a calculator. So I'm going to have Wolfram Alpha's calculator available. Yeah, let me have this set up here. Probably this is enough writing surface, and most of the time I can just do direct calculation. So let me get a sip of my coffee and get myself ready. And I say I'm not competing with the ChatGPT on time because I think I'll lose, and I really would rather beat it on accuracy. But I'll try to go through as quickly as possible. And one thing that does mean is that I'm not going to be explaining a whole bunch. If you want the explanation, hey, take a screenshot and ask ChatGPT. It'll probably give you a correct explanation. So with that, let me start. Alright, one-dimensional, net electric will be zero, okay. So here fields will be adding, so I need to place it here, I think, so that field from here and here can balance out. Suppose to 10 microcoulomb, most correct statement. Alright, so I think this is my test charge. Completely remove the setup. Yeah, because it's test charge. No. Oh, wait, so that is correct, right? Yeah. Value depending on what charge. Yeah, no, this is the test charge. Yeah, that's fine. Force is dependent, field is not. Static force, inverse square law, which means, I think this one. I got the question before. Flux through surface has been calculated, about to be done. So flux doesn't change. This was, you did this in lab, worksheet lab. Oh wait, but field, no, there, like here it'll, I think, get weaker. Weaker? No, here it'll get weaker. Negative charge. No, here it'll get weaker, I think. Because doesn't have total flux. No, that's still wrong. Flux through the, no, flux won't change. Flux through, wait, what? What did I miss? If no, this isn't right. Negative charge. Electric field between the two charges. Yeah, that's right. Here is not between the two charges. Sorry, this is a reading question, not a physics question. Some of the questions are like that. My recommendation when you see something like it, skip it. Like time you spend on it is not worth it. Which surface is the most positive net flux? So I'm just counting the charges. So I think S6 has the most charges being enclosed. S1 contains this. Yeah, no surface contains this and that. So it will be S6. Most positive, right? Yeah, this is also randomized. Sometimes it will say different things. In application of Gauss's law to find the electric field, closed surface. I think I got this question before, right? This one, yeah. I've seen it before. Just gonna go through it quickly. To conducting, radius. Voltage applied smaller sphere over time. And they are conducting, yeah. So voltage applied here is the same voltage everywhere. As voltage increases, there should be like electrical breakdown. It'll happen around the smaller sphere because the electric field around this is bigger. No, like even vacuum has a dielectric breakdown at some point. Electrical spark of business, not from the larger sphere. will descend starting from the smaller sphere, not ending on the larger sphere because they're at the same voltage. Starting from the smaller sphere, ending on near, yeah, like if it, like the spark from a Van de Graaff generator. Imagine putting together a positive uniform quotient of charges. Oh, I think I got this question before, right? Work needs to be done. Yeah. So there's the factor of 2 from the reasons I was talking about earlier. Electron volt is one of the most commonly used. Why? In a circumstance in which more convenient. Okay. Usually when you're dealing with elementary charge like electron or ions or energy, so macroscopic charged object, maybe not the best answer. Let's see. Describe microscopic phenomena where the quantity often, yes, but not the one I like the best. Let's keep going. More convenient joule in all circumstances? No. I mean, it is a natural energy unit, but no. I wouldn't describe energy of my car in electron volts. When other conditions such as velocity, maybe not. I think this is the best one. Yeah. Macroscopic charged object, they might not have elementary charge on it. So, 1 coulomb is a large amount of charge. Yeah, 1 farad is large. Now, the real 1 farad capacitors exist. I have an example in lab. Ask me about it once. It's got really low breakdown voltage because I think the distance is so small. Area A needed. So I happen to have the formula memorized. I think capacitance is area times epsilon naught divided by D. So I'm saying that's equal to 1 farad. So solving for area, it'll be times distance 0.1 millimeter divided by the permittivity of free space, or sometimes called the electric constant by Wolfram alpha. That should give me an area. An area for that should be 1 followed by 1, 2, 3, 4, 5, 6, 7 zeros. Yeah, that looks, oops, that looks right. All right, how much time? Yeah, I didn't beat it on time. I spent about 1 minute and 10 seconds more than ChatGPT, but I did answer everything. Do I want to double check, given that I already lost on time? I think I did my best. If I didn't get 100%, then it will be embarrassing, but what am I gonna do? It's already embarrassing enough to lose to ChatGPT on time, but so but I beat it on accuracy. So in the world, the best chess player now is not a human being, it is a machine, the stockfish. So I do believe at lower level performance, like answering multiple choice questions, which frankly are not that hard. Even the trickier questions, not that hard. I think at some point ChatGPT will be better than me. Like it's already better than me in terms of time. If I try to beat it on time, I'm pretty sure I would have made a mistake on something. So I decided to beat it on accuracy, and at some point it'll get 100% reliably. So at some point on like a low level cognitive test, like answering multiple choice questions well, at some point ChatGPT will be better than me, and my goal is to keep up as long as I can, like so that's the only achievable goal, not to beat ChatGPT forever, but to hold out as long as I can, knowing that eventually I'll be defeated. All right, so with that, yeah, I see that. Does that scare you that it's getting accurate? That is why I'm so happy that for the purpose of grading, I rely on my required one-on-one meeting. In the required one-on-one meeting, I'm testing your knowledge of physics, and not relying on if you know how to use ChatGPT. And so, if you are using ChatGPT to help you learn, like I've been demonstrating with the problem sets, and even with something like this. So let me do this as a kind of a demo. So on that one question that it got wrong, so imagine, you did it yourself. You weren't cheating like I was, but you did it yourself, and then you are trying to figure out, oh, what did I miss? And you have a suspicion, well, I got everything else, so I must have missed this. Then one thing you can do that I fully endorse is you can try with a generative AI, see if you can, it can tell you why you missed it. So something like this. But I guess the direct answer to the question, yes, it scares me a little, but not too much, because for the purpose of grading, I've set up things in this class where someone who's cheating will not get a higher grade through their cheating. So in terms of what I need to ensure is for my professional duty as your instructor, I think I'm all set. So I'm not worried about that yet. What I'll be worried is if there's like a wearable device that you can wear, and then in the required one-on-one meeting in person, if I can ensure that what you are saying comes from you, that'll scare me, because then what else can I do? I think I got this question wrong. Can you help explain? And it might get that right. Let's see. Voltage difference between A and B is inversely incorrect. B is higher. So that is correct. A is higher, so it should incorrect. B is independent of. So it keeps saying, but I think once you narrow it down to, well, it's either this or this, hopefully you can reason it through. But isn't number 2 correct also? Yeah. So let me say number 4. I think the question is holding the charge constant, not the voltage. Is that still a correct statement? Yeah, hopefully as you're reading this, you figure out, because you are a thinking human being, you realize, oh, it's just twisting itself in knot, trying to hold on to something that's wrong. So yeah, by the way, this is one, I would say, potentially academically honest way to use generative AI in connection with the multiple choice timed assessment. You can, because when you do it, the system won't give you the correct answer, and I do recommend that you study between attempts. And while you are studying, so you are not using generative AI while you are attempting it, you are using it after you've attempted it. You are using it while you are reviewing. If you are using ChatGPT to help you figure out what's the correct answer, then great, that I have no objection to, and that is not something that the rules prohibit.